You know that feeling, right? That little moment of panic when you plug your phone in and absolutely nothing happens. No buzz, no charging icon, just a black screen staring back at you. It's so frustrating. But what if that phone isn't really dead? What if it's just a mystery that we can solve? Well, let's grab our detective hats because we're about to crack this case wide open.
So that's the big question, isn't it? Is this phone a goner, or is it just playing dead? You'd be surprised how often a device that seems totally broken is actually just one small fix away from coming back to life. So let's follow the evidence and see where it leads us.
All right, every good investigation starts with gathering some clues. We're not going to just guess what's wrong. Instead, we're going to pull out some special tools to see what's really going on inside this thing.
So here's our detective's toolkit. We've got a multimeter. That's going to check for a pulse, basically the battery's voltage. Then there's the current meter, which tells us how much power is actually flowing. And that external power supply? That's our secret weapon. You'll see why in a minute.
Okay, so there's a magic number in the world of phone repair, and it's 3.7 volts. You can think of it like the "you must be this tall to ride" sign in an amusement park. If a battery doesn't have at least 3.7 volts, the phone's brain won't even wake up enough to tell you the battery is low. It just stays dark.
And here's our first major clue. We put the multimeter on the battery and what do we get? Just 3.3 volts. That's way below our magic number. So this tells us something huge. The phone isn't dead. Its battery is just so completely drained that a normal charger has no idea what to do with it.
So, since the battery is in this super low state, we can't just plug it into the wall. The phone's own charging system won't kick in. We have to step in and perform a special procedure to bring this battery back from the brink.
The process is called boosting, and it's kind of like using a defibrillator. We take that external power supply from our toolkit and give the battery a direct jolt of energy. We're bypassing the phone entirely just to get that voltage back up to a healthy level so the phone can finally recognize it.
And success! After a little boost, the phone flickers to life. We see a charging icon. So we're done, right? Case closed? Whoa, not so fast. This is actually where the real detective work begins. All we've done so far is treat a symptom, not the actual disease.
See, the phone's screen says it's charging, which is great, but our current meter, our little truth detector, is telling a very different story. The amount of power actually going into the battery is just a tiny, pathetic trickle. Something is still very, very wrong.
And this brings us to a really key idea: amperage drop. If voltage is the potential for power, amperage is the actual flow. It's the speed at which the battery is filling up. With a super low amperage draw like this, yeah, the phone might be charging, but it could take all day just to gain a few percent.
The source material we're looking at has the absolute perfect analogy for this. Think of it like a water pipe. We just jump-started the battery, which is like pouring a big bucket of water directly into the tank. But the main pipe that's supposed to fill that tank, it's clogged. And that clog is our real culprit. And right here, this is our smoking gun, the hard data. A healthy phone should be pulling in more than 1 amp of current when it charges. Our patient here, it's struggling to even get to 0.3 amps. The evidence is overwhelming. The clog is in the charging connector. Okay, so we've identified our culprit. Now it's time for the fix. And this isn't a software update. This is a hardware problem. It's time to scrub in and perform a very delicate operation, replacing that faulty charging connector right on the motherboard.
The whole process is really precise and honestly kind of cool. First, you use a special heat gun to gently lift off that old clogged connector. Then you line up the new one, and with a little more heat, it just snaps perfectly into place. And finally, you clean everything up so the connection is perfect.
All right, the new connector is in place. This is the moment of truth. We need to run our tests one last time to see if the operation was a success. Did we really solve the case?
And would you look at that? That is a beautiful number. Our current meter is now reading a super healthy 1.2 amps. That's the proof right there. We didn't just fix the symptom, we found the clog, we removed it, and now the power is flowing free and clear. That pipe is wide open.
And with that, this mystery is officially solved. The phone isn't just showing a charging icon, it's actually charging. It's going from 1% to 2% in just a couple of minutes, something that would have taken forever before. The case of the dead phone is now closed.
And you know, this whole thing leaves you with a pretty big thought. This phone was about to end up in a landfill, all because of one tiny, replaceable component. It really makes you wonder, doesn't it? How many other things we call broken or dead are just waiting for someone to find that one tiny clue and bring them back to life?